You know, you walk into a massive sports bar on a Sunday, or maybe you've seen footage inside a secure government facility, right? And there's 100
Oh
screens.
yeah, perfectly synchronized.
Right. Perfect audio, no tangled cords, it just works. But behind the drywall is this staggering hidden infrastructure. So today, we're doing a deep dive, tearing down that drywall.
Yeah, it's long overdue.
We're using this massive catalog from a 25-year-old industry hub called HDTVSupply to explore the unseen web of commercial AV. Okay, let's unpack this. We are actually starting with a single point of entry, the Turtle AV dual analog XLR input to Dante wall plate.
Which is honestly the critical first domino in the entire chain.
Wait, looking through this massive stack of sources, we have schematics for like 160 screen routing servers, and you want to start with a tiny wall plate. I mean, I have to push back here. Why does this single piece of hardware matter so much?
Well, what's fascinating here is why that specific plate is the absolute linchpin of modern AV. It's the exact boundary where traditional analog audio just ceases to exist.
Right, because it's digitizing it.
Exactly. You plug an old school XLR mic into that plate, and it doesn't just, pass voltage down a copper wire. It instantly packetizes that audio into a networking protocol called Dante.
So instead of a continuous electrical signal, the audio gets chopped up into data packets, basically like sending an email.
Precisely. Once it hits that plate, it's just pure network data. It gets an IP address, and that means it can be routed anywhere across standard network switches without any signal degradation at all.
Whether it's traveling
Right.
50 feet
Or across a massive stadium campus.
It's essentially a massive digital postal sorting facility. Every packet of AV data gets assigned a dynamic IP zip code. So next time you're in a venue, look at the walls. That audio is likely being digitized right at the source.
Right, rather than running through miles of heavy copper wire.
But turning all that AV into IP data, I mean, that creates a massive traffic management problem, doesn't it?
Oh, absolutely, it does. Which is why that data needs a director. It hits a matrix switcher. And the sheer scale in this HDTV supply catalog is just mind-bending.
Yeah, I saw they list over 2,000 of these Wolfpack modular matrix switchers.
Yeah, we're talking systems that start at small 4x2 setups and scale all the way up to 160 by 160 HDMI matrices running entirely over standard CA6 network cables.
Wait, a 160 by 160 matrix over CA6, that completely flips how you design a building.
Totally.
Because the physical architecture no longer dictates the AV layout. You aren't bound by the strict distance limits of traditional HDMI cables anymore.
Right. If we connect this to the bigger picture, that decoupling is exactly why high-end sports bars use these systems. They can control dozens of TVs from a single tablet, like a Wolfpack.
Oh, wow.
But it's also why mission-critical government operations rely on them so heavily. You'll actually see these massive chassis purchased through federal GSA schedules and TAA-approved programs.
Which guarantees the hardware meets strict U.S. government security and manufacturing standards, right?
Exactly. When you are routing sensitive data across a military campus over a standard IP network, you need that certified security.
Okay, so we've packetized the signal at the wall plate, routed it securely through a massive matrix switch, but how do we actually reconstruct it? Like, if a command center needs to stitch that signal across a massive 10 by 1 video wall with complex picture-in-picture layouts, how does it not just lag or crash?
Well, that requires highly specific video wall processors at the end of the line. And the key distinction here is native hardware processing.
Ah, got it.
Yeah, if you try to pixel map a massive 4K 60 Hz canvas across 10 screens using software on a standard PC, you introduce latency. The CPU inevitably gets bottlenecked.
Right, because software has to interpret the data, render it, and then, push it out to the graphics card.
Exactly. But these dedicated processors bake that rendering directly into the silicon. They handle the heavy lifting natively at 4K 60 Hz.
So a single user can command these massive visual canvases instantly.
Yeah, the processor physically addresses every pixel across that 10-screen array instantly, allowing you to drag, drop, and resize feeds without even a microsecond of delay.
That is wild. So from a single Turtle AV wall plate digitizing an analog mic pulse to a massive Wolfpack matrix routing AV over IP to 160 different screens.
And then to a hardware processor seamlessly rendering 4K across a massive grid.
Right. The invisible web of commercial AV distribution is just an absolute marvel of IT networking.
It really is. It takes that initial illusion of magic and replaces it with an engineering reality that's honestly infinitely more impressive.
It really makes you wonder about the future of our own setups. As these massive audio and video matrix systems fully merge with standard IP data networks in the commercial space, will traditional dedicated AV cables eventually go entirely extinct?
That's a great question.
Right. Are we moving toward a world where everything, even the entertainment in your own living room, runs purely on standard computer data networks? Think about that the next time you look at the maze of wires behind your TV.